Welcome to True Projects. In this video, we are going to explain about the project which is benchmarking scalable predictive uncertainty in the text classification. Introduction. In various fields like healthcare, autonomous vehicles, and document processing, machine learning models play a vital role in decision making. However, their tendency to offer predictions without indicating uncertainty poses challenges in detecting limitations stemming from training data, designing flaws, or unexpected data changes. This project focuses on meeting the critical need for reliable uncertainty estimation in machine learning systems, particularly within natural language processing text classification tasks. Text classification is pivotal in various applications including sentiment analysis, document categorization, and spam detection. The project tackles overconfident predictions in text classification caused by data distribution shifts. It aims to make NLP models more robust by benchmarking scalable Bayesian deep learning methods, ensuring they adapt to changing data patterns and convey uncertainty when faced with new text categories or distribution shifts. The project involves testing multiple models including naive Bayes, BERT, Robota, GRU, LSTM, CNN, and Ensemble model. Objective. The main goal of this project is to enhance the reliability and applicability of text classification models in natural language processing by improving predictive uncertainty estimation. This will contribute to more informed decision making and increase trust in NLP models. We aim to utilize various algorithms including scalable Bayesian deep learning methods such as naive Bayes, BERT, Robota, GRU, LSTM, CNN, and Ensemble models. These algorithms will help by providing more accurate and realistic measures of predictive uncertainty, allowing for better model calibration, enhancing model robustness by accurately identifying uncertainty, especially when faced with novel or out of distribution data. The ultimate goal of this project is to develop a text classification model that offers trustworthy and well-calibrated predictions with accurate estimates of uncertainty. Requirements for the project are hardware and software. In hardware, operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. In software requirements, we need Anaconda 3 and Visual Studio Community version. To execute the project, we have designed few modules in the flow of work. The first one is importing the packages. This module involves importing the necessary libraries and modules required for the project's execution. NumPy is imported for numerical operations, Pandas for data manipulation, TensorFlow for deep learning, Matplotlib for data visualizations, Seaborn is also for visualizations, Scikit-learn for machine learning, Transformers used for natural language processing. Exploring the dataset. The process data. In this step, the module involves data exploration and analysis, focusing on gaining insights and understanding its structure. Data processing. This module is responsible for pre-processing the dataset, which includes tasks like data cleaning, handling missing values, and transforming data into a suitable format for model training. Visualization using Seaborn and Matplotlib. In this step, the module involves creating visualizations using the Seaborn and Matplotlib libraries to visualize data trends, distributions, and relationship between variables, aiding in the data analysis. Data cleaning. This module involves tasks related to data cleansing, including removing duplicates, handling outliers, and ensuring data consistency to prepare the dataset for further processing. Tokenization based on BERT for transfer learning and Keras for deep learning. This module involves tokenization where the data is converted into numerical format for model training. It utilizes BERT tokenization for transfer learning and Keras tokenization for deep learning models. Splitting the dataset into train and testing. In this step, the module divides the dataset into training and testing sets, which are essential for training and evaluating machine learning or deep learning models. Building the model. In this module, various machine learning and deep learning algorithms are employed to construct models for the text classification or emotion recognition task. Each algorithm serves as a specific purpose in this project. Here are the algorithms used and their respective roles. Naive Bayes. It is a probabilistic algorithm based on Bayes' theorem with the assumption of independence among the features. It is commonly used for classification tasks. It is employed in text classification due to its simplicity and efficiency. It is particularly effective when dealing with high-dimensional data like text, where the independence assumption simplifies calculation. It is used as a baseline model to quickly assess the performance. BERT, which is a bidirectional encoder representations from transformers. It is a transformer-based deep learning model that is pre-trained on massive amount of text data to learn contextualized word representations. It is used for various NLP tasks. It is used because it excels at capturing contextual information in the text, which is crucial for understanding the meaning and the sentiment behind the words. It is employed when high-quality, context-aware embeddings are needed for text classification. Robota, a variant of BERT, that refines the pre-trained process by using more data training strategies. It is also used for various NLP tasks. It is used when improvements over standard BERT performance are desired. It is more powerful transformer-based model that can provide better results in certain NLP tasks. GRU, LSTM. GRU and LSTM, which are gated recurrent unit and long short-term memory, these are the architectures designed to capture sequential dependencies in the data. These RNNs are used when order of words or sequences in the text matters. They excel at understanding and remembering sequential patterns, making them suitable for tasks like sentiment analysis and emotion detection. CNN, which is Convolutional Neural Network. CNN is a deep learning architecture originally designed for image processing but adapted for text data by treating text as 1D sequence. It is employed when capturing local patterns and features in the text data is important. They can identify important word combinations and structures within the text, making them suitable for certain text classification tasks. Ensemble model. An ensemble model combines predictions from the multiple base models to make a final prediction. It is used to improve overall model performance by leveraging the diversity of different algorithms. They can reduce overfitting, enhance model robustness, and boost prediction accuracy. They are used when seeking to maximize predictive power. Training the model. This module focuses on model training, where the machine learning or deep learning models are trained using the training data to learn patterns and the relationships within the dataset. Flask framework with SQLite for sign-up and sign-in. In this step, the module integrates the Flask framework with an SQLite for the database for user registration, allowing users to create accounts and access the application securely. User gives input. This step involves users providing input or data through the application user interface, which will be used by the prediction for the model. The given input is translated and pre-processed for the prediction. This module takes the user input, translating it into a suitable format, and then it pre-processes it to ensure compatibility with the trained model. Trained model is used for prediction. Here, the module employs the trained machine learning or deep learning models to make predictions based on the pre-processed user input. Final outcome is displayed through frontend. This last step involves presenting the model's predictions or the results to the user through application front-end interface, providing the user with the desired output or insights. For execution, first we need to open the code folder of the project. This is the code folder of the project. This is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This file contains information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. And these are the model files which contain the algorithm information, and these will be loaded into the project code during runtime. And this is the IPYNB file, and this is also the IPYNB file. And this is a Jupyter notebook file which contain a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells. This is the sign-up file. This file is the database file used to store the user information. Now we need to copy the path of code folder from the address bar of the file explorer. So we will copy this path. Now we need to open the Anaconda prompt. Using the cd command, followed by the space, we need to paste the copied path. This is used to change the current directory to the code folder's path. Now we will click on enter. So here the current directory is changed to the code folder's path. Here we need to type python space app.py. This will compile the app.py file, and this will perform a runtime check for any syntax errors or logical issues. Now we need to click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is localhost, and the port number unless configured differently. So this is the localhost and this is the port number. We need to copy this local link provided by the Flask framework and paste it in any browser. So I'll copy this and paste it in the Google Chrome. So here we will paste the link and then click on enter. So here we can see the homepage of the project, which is displayed in the browser, and this front end is built by using the Flask framework. Now we need to click on login. So here we need to fill all these registration details if we are registering newly. I have already registered, so I'll directly click on sign in. I need to fill my username and the password, which are my credentials, so that I'll be logged in. And here I'll give my password. Now I'll click on sign in. So it has redirected to the page where we need to give the input message in the text box. For that we will be getting the predictions for that particular text. So here we will give the text. So I have given the text here. Now we will click on predict. So based on the given input, it is predicted that the sentiment of the tweet is sadness. Now we will give one more tweet. I have given here the message. Now we will click on predict. So based on the given input, it is predicted that the sentiment of the tweet is anger. Now we will give another tweet. So I have given the message here. Now we will click on predict. So it is predicted that the sentiment of the tweet is love. Now we will give one more tweet. I have given the other message. Now I'll click on predict. It is predicted that the sentiment of the tweet is surprise. Now we will give another message. I entered the message here. Now we will click on predict. So it is predicted that the sentiment of the tweet is fear. Now I'll give another tweet. I entered the message here. Now we'll click on predict. So it is predicted that the sentiment of the tweet is happy. In this way, we can give the messages, and for that we will get the predictions whether the sentiment which the tweet is happy, sad, feared, angered or loved. Now we will sign out of the web page. The project successfully boosts the accuracy of emotion classification techniques, resulting in more dependable predictions for emotions like love, sadness, fear, anger and surprise. Accurate uncertainty estimation in emotion analysis strengthens the model's ability to handle subtle emotional nuances, ensuring more trustworthy outcomes. These enhancements render NLP models more practical for real-world applications requiring emotional analysis, including sentiment analysis, customer feedback assessment, and content recommendation based on emotions.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.